Okay, factoring review 3a. Just more of the same. Factor the following. Except the expressions here, these are a little bit more complicated. Okay. Now, this one right here, the first thing we're going to do here is look for what's common. Okay, we got the 3 and the 5. Oh, okay, as soon as you got the 3 and the 5, these are prime factors. They don't share anything in common, so there's nothing in common in terms of the coefficients. I got x squared, x. Okay, I got a y there. Well, all of a sudden now there's no variable that's common to all of those terms, so I don't worry about it. So what I'm going to do now is I'm going to group together terms here. But watch how I do this. I'm going to put brackets around the first two terms, plus I'm going to put brackets around the last two terms. Now, the error that will get made here is people are going to try to push that negative out right away. But if you do that, if you put a bracket in between there and push the negative out, in a lot of cases here, what you will have done is factored out a negative inadvertently from one of those two terms and not both of them. And you'll get it wrong. Okay? You're better off splitting this into two steps and combining that negative with those two terms here. Always put a plus sign in between. Okay? You'll be happy you did. And now what we do is we take a look inside these parentheses. What is common? A common factor between 3x squared and 5x. Well, certainly not the coefficient, so it's got to be the x. And it'll be x to the least exponent, which is just x to the 1. And so I'm left with 3x plus 5. If you distribute the x back through to those two terms, you'll retrieve that 3x squared plus 5x. Over here, between those two terms here, now I'm going to notice that negative is common between those two, and so I'm going to pull out a negative term here. Again, if you go back to the original, if you group that together and separate that negative out from the 10y, you've only factored it out of one term. I need to factor it out of both. Between 10 and 6, there is a common factor of 2, negative 2, so I'll pull that out. And then in the variables here, I notice there's a y common to both of those, so I pull that out. Okay, and so really what I'm doing with common factoring is I'm going backwards with distribution. So we've got to think about this. If I was to go forwards with this, I would distribute negative 2y to two terms to get negative 10y minus 6xy. So what would this have to be? Well, to get a product of negative 10y, this would have to be 5. Okay? To get a product of negative 6xy, when I multiply something by negative 2y, this would have to be plus 3x. Okay? Now, compare these two terms, because remember, there are now only two terms here. There's this term and this term. The multiplication with the parentheses, that groups that together as one term, and groups it together as one term here. If you're having a hard time seeing that, remember what we've done in the past here is I've looked at this and said 3x plus 5. Now, you have to notice here that 3x plus 5 and 5 plus 3x, order does not matter for addition, so those are the same. So if you're having a hard time kind of to seeing what to do at this point here, the reason you're having a hard time is because of those binomials. Just relabel it. Let's call 3x plus 5, let's call it a. So then this expression becomes x times a minus 2ya. And now I can see quite clearly that the variable a is common to both those terms. And if I take that out, then the a has been distributed to x minus 2y. Okay? And that would be the answer in factored form. But I got to take it one step further because a was not part of the problem. So I have to write down what a was, and that becomes 3x plus 5 multiplied by x minus 2y, and that is the final factored form of question 3a.